immense universe, stretching through the vastness of space, is our nearest neighbor, the moon. Man actually has walked on its dry, dusty surface. We now know it is barren, desolate, devoid of even the simplest forms of life. What a contrast to our planet Earth, a sphere of striking beauty, fresh, fertile, green, and teeming with life in great abundance. What makes the difference between the lifeless moon and the living Earth? Water makes the difference. There's nothing else like water in the entire universe. And yet on Earth there's a great abundance of it. It covers about 70% of the Earth's surface. That's an estimated 326 million cubic miles of water. If the surface of the Earth were perfectly smooth, the waters of the ocean would cover our planet to a depth of between 8 and 9,000 feet. And while it's true that only a fraction of all the water on Earth can be called fresh water, or water suitable for our own personal use, that fresh water comes to us through a water cycle that daily lifts from the oceans millions of tons of water, leaving behind the salt and dropping the fresh water as rain upon the earth. In the water cycle, water vapor is created by the heat of the sun. And the water, the sun, the air, and the force of gravity work together as they have for centuries to keep what is known as the water cycle going. Warm air is lighter than cold air, which causes it to rise. These clouds began as rising currents of warm air laden with moisture. Prevailing winds help the process along by pushing the moist air up steep mountain slopes. As the air rises, it cools. And as it cools, it contracts, literally squeezing out its moisture, which falls to the earth as refreshing rain. As the raindrops fall, they wash the air, absorbing carbon dioxide and reaching the earth as a mild solution of carbonic acid, or fresh water, needed for plant, animal, and human life to survive. Evaporation, condensation, and precipitation. These make up the water cycle, which is continuous, occurring over and over again somewhere every moment of every day. Think of the energy involved. More energy is expended in the water cycle every 24 hours around the planet Earth than man has been able to generate throughout the course of history. And the water cycling process is so successful that up till now anyway, the most extraordinary thing about water is just how ordinary it really is. Vital to life, yet available in great abundance. And because of abundance, it's an easy thing to disregard the value of a substance. Ordinary water. How much would you say it's worth? Actually, it's priceless. Did you know it takes 300 gallons of water to make one loaf of bread? 700 gallons for 1 barrel of petroleum? 4,000 gallons for 1 pound of beef? 10,000 gallons for 1 automobile? Hay, dry as it may seem, is over 60% water. The same thing is true, only more so, of every tomato, every carrot, every apple. 250 tons of grain represent an intake of 150,000 million tons of water. Every day we buy products that are largely water, or it took a lot of water to make them. But even more important is the role water plays in the functioning of your own body. About 70% of the average human body is water. In one way or another, you keep losing this liquid, and if it's not replaced, then fairly soon, you will die. It's the water in your blood that carries it through 60,000 miles of arteries, veins, and branching capillaries. Water plays a major role in the digestion of your food. It serves to lubricate your joints. Your mucous membranes would dry up without it. Without water, your eyes would cease to function. As you work or exercise, it's the water that regulates your body heat through a process called perspiration. Right at this moment, as from the beginning of time, water is supporting life on Earth. And so far as we know, there is nothing else like it in the entire universe. It seems to have been expressly designed to make the planet Earth hospitable to life, your life. Even so, with the gift of water comes a responsibility. We've been so blessed with this gloriously abundant, yet tremendously vital substance. Drink it, breathe in it, walk through it, compete in it, take what we want out of it, dump what we don't want back into it, and hardly give it a second thought. But now a question arises. A question that bothers people interested in ecology, or the relationship of organisms to one another and to their environment. The question is, how long can we abuse this common necessity without losing it? What do you think is the answer?